All right. Zoom in. Why don't you move closer, Anar? Come on. I got to fit this on this big screen. So look, before I even get started here, kids, the n on the bottom, remember, a number over n doesn't converge. All right, unless it's alternating. Does that make sense? The x to the n on top is going to battle with the 4 to the n. Cool. 4 to the n needs to win. If x to the n wins, it's going to get bigger, 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 bigger. So the interval of convergence for this, before I even start, has to be between -1 and 4. Right? If 4 to the n has to cancel, then we'll have 1 over n. All right, and then we check those endpoints. That's what has to happen here. If you look at b, that's an n factorial times something. What's n factorial going to do to an exponential? Yeah, it's going to win. Yeah, it's going to beat it up. Okay? So look, even if this exponential here becomes like 1/2 to the n, that's going to go to 0, right? But if you put an n factorial in front of it, that wins. N factorial is going to blow up way bigger than 1/2 and then get smaller. That means that thing, I'm just showing, I'm playing them real quick. That's going to diverge everything, except for the center. There's an n factorial on top. It's going to take it. There's nothing to battle. There's nothing to make it smaller. Make sense? Okay, so that's going to diverge everywhere except for the center. Here, we have a 1 over n squared. That's the only thing on the bottom. Okay, and then we have something to the nth power here. Who's going to win that fight? The nth power, unless I'm raising something small, like a 1/2 to the n, right? So I need this thing in here to be between -1 and 1 is what's going to happen. Okay, that's like, I'm just the reason. You don't have to be able to do that. You can look at it a little bit and have that kind of idea. I'm going to show you how to do all the work out. Okay, but having some intuition about it just makes this like a little bit easier. So anyway, let's come up here. We're going to do every single one of these with the ratio test. So we're going to start with the limit as n goes to infinity. I want y'all to pay attention to how I'm writing this, because some of y'all are writing it super duper sloppy and not really checking your endpoints correctly on that last quiz. Okay? The n plus 1 term is x to the n plus 1 over n plus 1, 4 to the n plus 1. We're going to divide that by the nth term, which looks like this. I'm hoping at this point we're okay reducing these down. The only thing left here is going to be an x over a 4. And look, there's really an n over an n plus 1 sitting here. But where is that going to go as n goes to infinity? 1. Right? So that just goes to 1. And now there's no n's left. So I'm going to write it out. But I don't think you really need to. Like, that's still sitting there. But then we still have this limit. This x over 4 has nothing to do with that limit. It says n goes to infinity. Okay? So that fraction becomes a 1, and what I'm really left with is, and this should be absolute value, but the absolute value of x over 4, and that needs to be less than 1 by the ratio test rules. And remember I told you, when you're doing this, you want to get the center, the absolute value of x minus the center by itself. The center is 0, so I need to get absolute value of x by itself. We need absolute value of x to be less than 4. That means from the center, which is 0, I can go up 4 and down 4, which makes the interval of convergence -4 to 4. But then we need to check the endpoints. So I'm going to do that somewhere. There's not a ton of room here, but I'm going to write check x equals -4. And I can see that if I put a -4 into here, we get -4 to the n over n times 4 to the n, which reduces all the way down to that. What's that series going to do? Converge by alternating series test. But you got to show that. So under there, I'm going to write 1. The limit as n goes to infinity of 1 over n is 0. Check. 2. 1 over n plus 1 is most definitely less than 1 over n. So this converges by alternating series test. Okay? So we can include -4. Then we're going to check 4. So don't have a ton of room here. I'm going to do it right in here. Huh? Oh, it can be 1. You're right. So that should be a 1. That doesn't change too much. Okay, so check x equals 4. If you drop a 4 into there, like these shouldn't be crazy difficult, it becomes 1 over n. That diverges by p-series test. Okay, on the AP test, they write harmonic series diverges. That's the harmonic series. Okay, but can you do what? It's just 1 over n. That's just the name of it. Cool. Diverges by, we say p-series, but it's the same thing. So we can't include 4. That's what that question looks like, kids. The ratio test, write the interval, check the endpoints, tell me why they diverge or converge. Okay? We're going to keep going. Okay? For B, a little bit easier, less work. The limit as n goes to infinity of n plus 1 factorial x minus 5 to the n. And now instead of multiplying by the reciprocal, since this isn't a fraction, I'm just going to divide by the nth term. Absolute value. Hopefully everybody knows this. How about me on that? Where's that limit going? So in our last limit, look, our last limit we did, all the n's went away because they went to 1. And we just had some left over, we solved for x, right? X minus the center. Here, all my n's did not go away. If that n was in the denominator and n was going to infinity, where would the limit take it? To 0, and it would converge everywhere because it's always 0. But since it's in the numerator, this is going to go to infinity, which means it's going to diverge everywhere. And the only time it will not go to infinity is if x is what value? Not 0, 5, right? Because it doesn't matter how big this gets as long as you're multiplying it by a 0. So this only converges at x equals 5. That's it. Cool. Just because that happened here doesn't mean that's going to happen on the test, kids. It might have an interval of questions. I'm not sure. All right. And then for this last one, we're going to do the limit as n goes to infinity of 3x plus 2 to the n plus 1 over n plus 1 squared times n squared 3x plus 2 to the n. Okay? And again, I'm going to skip a step here. I know you love when I do that. But for time's sake, oh, we got 10 minutes still. Awesome. Do you see how we're going to have n squared on top and n squared on the bottom? That's going to go to 1. So the only thing we really have left here is the absolute value of 3x plus 2, which means there's no n's. Is that okay? The limit is done. I need what I have left to be less than 1. Okay? Now, what I'm telling you is you need, when you get to this step, to get on the left-hand side here in the absolute value, x minus the center. Okay? Not 3x, 1x minus the center, which means what do I need to do? Well, we're not going to subtract 2, we're going to divide by 3. Yeah, you don't want to move you don't want to subtract and add. Okay? You just want to get to the x plus something or x minus something. For that to happen, I need to divide everything by a 3. That makes this, and I'm going to write it like this so we can see what the center is. X, it should be plus 2/3. I'm going to make it minus negative 2/3. Everybody okay with that? So my center is negative 2/3, and I can go 1/3 up and down from it. If I go up 1/3 from negative 2/3, I'm going to get negative 1/3. And if I go down 1/3 from negative 2/3, negative 1. So we're going to check both endpoints. Check x equals -1. If you plug in -1, do this kind of quickly, that becomes -1 to the n in there. So we have -1 to the n over n squared. And we're going to say that that converges by p-series. It's alternating, but I don't think we're running like crap out. That's just the p-series. What's up? You okay? No, there's no limit here. That's just the series that becomes. So this converges by p-series. Now we're going to check x equals -1/3. So again, this check series shouldn't be too difficult. It's going to be like alternating series test or p-series, something like that. This is still a p-series. Converges by p-series. Okay? So we can include both endpoints. What luck. We feel uncomfortable with that. It's a good face. We're ecstatic about the ratio test. Yeah.
I don't know if I'm stupid, but now just going back to the step where we did the ratio test for the n+1, and then you know how we like cancel both terms out. But wouldn't that still leave an n+1 on the bottom? You know what I mean? Like the n+1 is bigger.
Over here, you mean?
Yeah, that part.
No, so we're making it this, dude.
Yeah, n squared over n+1 squared. n+1 wins.
Yo, it matters the degree. The degree of both of them is 2. So as you go to infinity, they cancel each other out to their coefficients, which is 1. Okay, that's why. All right. Okay. A Taylor polynomial for ln of x centered at 2. It's kind of a pain in the butt. 4th degree means we need to derive it 4 times. And then we're going to plug 2 into those derivatives to get the derivatives for the series. So the first function is ln of x. The first derivative is 1 over x. The second derivative is -1 over x squared. The third derivative is 2 over x cubed. That's a cubed. And the fourth derivative is -6 over x to the 4th. We're going to plug 2 into every single one of those. ln of 2 is ln of 2. 1/2, -1/4, +1/4, like 2 over 8. And then -6 over, what, 16? So -3 over 8. Have I yet understand this process? We're building out the series. So I'm going to call this p sub 4 of x equals, the very first term is ln of 2 plus 1/2 divided by 1 factorial, which is a half, times x minus the center to the first power, plus -1/4 divided by 2 factorial, which puts 2 down the bottom, times x minus 2 squared, plus 1 over 4 divided by 3 factorial, which is 6, x minus 2 cubed, and then plus -3/8 divided by 4 factorial, which is 24, x minus 2 to the 4th. Sound good? Yeah.
That's how we get full points, like, on the test. You have to write it exactly like.
How else would you write it, man? Yeah. I mean, you could write 8 times 24, I guess, if you want. I mean, you could simplify it, but okay. What? So we want to plug 2.1 into this thing. We should have done this ahead of time. I don't want to record this, but whatever. ln of 2. I'm standing. You guys okay? I know it's funny for you guys because you're so nerdy. If I don't have dates to the prom, but people have to worry about that. Dates to the prom. Now you guys don't. Oh my gosh. 0.1 to the 4th. Kablow. 0.7419. And I'm going to check that. Ready? ln 2.1. Are you making fun of me back there? Look how close it is. So I'm going to have you guys write this out. I don't know, just to look different. Oh, man. 74193. That's just how good the series is, right? Yeah. 0193 73447 73447. Oh wait, that's correct, and that is approximately equal to the ln of 2.1. Thank you, calculator. Huh? Oh, darn it! Don't make that mistake, kids. -10. 19372847. There we go. Thank you. Go. Easy peasy. The next question says find an error bound for your approximation. So we are going to write, look at this. I'm going to type it out because I'm lazy, but you guys have to write it. Let me connect this key. Ready? Because now the series is alternating. Because the terms, now we can say the terms. The terms are alternating and decreasing in value. This is a convergent alternating series, and the error bound is the first unused term. And then we're going to write this out. Great. The first unused term. What do we got to do here? We got to find the fifth one, which means we need the fifth derivative, unless we know the pattern. And there is a pattern to these, but let's just derive it a fifth time. That's going to be 24 over x to the fifth, which is 24 over 32, right? Yes, which is 3/4. So the ln of 2.1, the actual answer, ln 2.1, right, minus my approximation in absolute value, because I don't know if it's positive or negative, must be less than the fifth derivative divided by 5 factorial, right, times, it's not, what was x though? Specifically 2.1, so it's really, okay, and that's probably fine to leave it like that, but we can do this. It's 3 divided by 4 divided by, that's 0.75, let's do it, 120 times 0.1 to the fifth, and you're going to see it's a super duper tiny number, 0.1, 2, 3, 4, 5, 6, 7, 6. Cool? 625, yeah. You can use that scientific notation, no matter. That's what that means. Cool? That's why our answers were so close together when I did ln 2.1 and what's it called? Sound good? Okay. Yo, I'll finish this up.